Welcome back to Outward Home Learning. The subject's computer science, and today we're looking at designing and creating algorithms. This is a really crucial topic for your understanding, and there's always lots of marks available in exams for this, so it's a bit of an extended one. Over to Mr. Holton, who's going to explain a bit more about it.
I'm going to show you a technique you can use to help sort of break down an algorithm, have a look at it and sort of see what the important parts of it are and what you'll need to code. And this is called an iPod table. It's something that we use fairly often with some success. And so to start with this, we're going to have an algorithm. So here we go. Let's read through this. Albert needs a program that will print out the next two numbers after the number that is entered, but only if that number is greater than 10. For example, if the number 34 was entered, the program should output 35 and 36. If 9 is entered, it should return nothing. Okay, so there's our algorithm. Here's how we use an iPod table. We have 4 columns. The first one is input, I for input. The next one is processing, and this is where a lot of the work gets done and possibly the trickiest part that you need to worry about. So process or processing. Then you have output. And finally, you have decisions. So any decisions that you need to make, okay? And let's start filling this out by example, and then you can see how this could be applied to other algorithms. So inputs first. Have a read of the text above and see if you can identify what the input is. So where am I putting in data to the algorithm, or where is somebody entering something in? Or providing data in another form. Could be letters, could be numbers, could be words, could be anything really. And if you have a read through, pause it if you need to, but if you have a read through, you will see that here it says after the number is entered. So I know that somewhere I'm entering in a number. So because of that, I'm going to write in my input column num1, the first number, num1. But only if that number is greater than 10. Let's come back to that later. Okay, so I've got to worry now about processing and output. So what gets printed out? So I've got Albert needs a program that will print out the next two numbers. Okay, so that gives me 2 clues actually. It gives me what I need for my processing and my output. So next 2 numbers. Now I've got to think about, I've got num1, I've got a number that's entered. How can I get the next 2 numbers? Well, that's going to be num1 plus 1 and num1 plus 2. Because I'm doing some maths here, and process really is a lot of, for simple algorithms, it's just some maths that you need to figure out. I'm going to create a couple of variables here as well to store the results. So I'm going to do total 1 equals num1 plus 1, total 2 equals num1 plus 2. Output then are those 2 variables that I've just made, isn't it? Because I've just figured out what the next 2 numbers are. So my output is going to be total 1 and total 2. Finally, I've got a decision to make somewhere. Okay, so I've got to make a decision because if you have a look, it says that I only do this if the number is greater than 10. So I've got to check somewhere if the number that has been entered is greater than 10. So for this you use comparison operators and things like that. So have a look at the operator video if you need to. But here I'm going to write, okay, num1 greater than 10. So using that table, I've identified what my inputs are, what my processing is, what my outputs are going to be, and what my decisions are. Okay. Now I need to use that to put it into some code. And once I've figured out all this, then I just need to know how to go from the table to the code. So the first thing, input. If I'm doing input, I want num1 equals input. And then an appropriate message here. So let's do just please enter a number. Our second bit is going to be processing. So this is where I'm going to work out the next 2 numbers. So I've got total 1. And here I'm just really copying what's here. And knowing what the maths is definitely a trick to the algorithms, that you have to just look at the algorithm that you're given and see if you can figure out what maths you might need to do. I've got a decision here, okay? So number 1 is greater than 10. And if I've got a decision, I would definitely want to use the word if, because that's to do with selection. So if num1 is greater than 10, then. Well, if I'm doing this in Python, it'll be a colon, won't it? So like that. And then I only want to print something out if num1 is greater than 10. So here I can go print total 1 and print total 2. And if you know your if statements, you will know that this code will only ever run here. These two lines will only ever run here if that if statement is true. So if num1 is greater than 10. So using that iPod table there, so I've broken down the problem into the different parts, the input, processing, output, decisions, and then it's just the case of mapping the different parts of the iPod table to the different parts of the code. Now this could be in pseudocode, just like I've done here, or it could be in a flowchart as well. So you can have a look at a separate video about flowcharts to sort of get an idea how you could do that. But you see how those 4 parts mix in, and that's how you can use an iPod table.
So it's time to open up your first task. For this one, you need to be able to identify the input, process, output and decisions from some algorithms that you are given. So you can put some of Mr. Holton's information into practice. You've got 10 minutes to complete this, then we will review your answers. So 10 minutes, off you go. Hopefully you got on okay with that. So as ever, we're going to go over to Mr. Barnes. He's going to walk through those answers. I recommend that you make sure you amend your answers if you need to, if you didn't get them completely right. So over to Mr. Barnes to review those for us.
Okay, so you should have watched a video about how to sort of decompose a problem and solve algorithms, and you would have talked about the process of iPod, identifying the inputs, processes, outputs and decisions, and that is a starting point to allow you to solve the problem. So hopefully you've had a go at that activity that you can now see on screen, and we're going to go through and have a look at the possible answers. So the first program we've got is create a program that asks the user to enter 3 test scores out of 100. It should then calculate and output the average. Okay, so inputs allow the user to enter 3 test scores. So we're going to have 3 inputs here, something like score 1, score 2 and score 3. Okay. Now process, this is normally for calculations, so it says it should then calculate and output the average. Okay, so to work out the average, or the mean average as it's referred to in maths, we're going to need some kind of calculation that says score 1 plus score 2 plus score 3 divided by 3, because there's 3 scores. It then says it should output the average. So our average is our output. In this problem, there are no decisions to be made. We don't need any if statements. Okay, let's move up a bit. Problem number 2 then says create a program that asks the user for the first name and surname of a person. Okay, so straight away, if we're asking the user for information, we've got some inputs. So we've got first name and surname. It should display the total length of first name and surname. Now there is a way to write this, but as this is an iPod table, it doesn't matter. So I'm just going to write count the length of first name and surname and add together. Okay, so then we've got if the length is more than 20 characters, it should output wow long name. Well, let's get the output in. So that will say wow long name. Okay, and we do have a decision to make here. The decision is what about the length? So we need to say is the length greater than 20 letters, or characters I should say. Okay, so we do have all 4 in this situation. Right, last but not least then, problem number 3. Create a program where the user enters the number of days they've worked. Okay, so straight away we've got an input. I'm going to call it days. The program should then ask them to enter the number of hours worked for each day. So hours worked is an input. And then output the total. Okay, so we're going to have a process here. Well, let's get our output first, total, because it needs to output that. So we somehow need to work out the total. So that's going to be adding all the hours worked together, and if we're going to keep repeating it, we are going to need a loop, but we'll come on to that in a second. So the process is going to simply be the total equals the total plus hours worked. Okay. Now the decision. The decision is how many times do they need to input these things? Well, it's dependent on the number of days. So we can just put in here, has the program asked the hours for each day worked? Because at the moment this is just planning. Okay, we need to worry about how we're going to do that when we come onto the real task, and the answer would be, well, it would be a for loop, because if they say they work 5 days, we know how many times it needs to repeat. So there's your walk through the designing algorithms activity. Now to move on to the next activity.
So your second task, I reckon, will take you roughly 20 minutes. It might take you a bit longer. that you have a series different levels of algorithms that you need to complete. Now, you can obviously select different levels if you think it needs to be a bit more difficult or a bit easier. And for these, you will review your own answers, because we've provided on the Google Slides on the website all of the answers to those algorithms, with Mr. Barnes walking through each and every one. So it's really important you take your time with these. These can be quite challenging, but again, you can work up the levels to set the correct level of challenge for you. Off you go. So that's time up. Now, I mentioned earlier that you need to review your own answers. So on the Google site, you'll see that we've got answers to all of those levels of algorithms. So you need to take some time to do that, press the pause button, and then come back when you're ready. So finally, there's some exam questions for you to complete based on what you've learnt today. You've got 10 minutes as ever, and then they will be reviewed afterwards. Off you go. Fantastic. I hope you got on well with that. Over to Mr. Barnes to review.
Okay, so now you should have had a go at some exam questions on creating algorithms. There's 2 of them in total, so let's have a look at these. So we've got here, taxi company calculates the cost of a daytime journey is £3 for the first kilometre and £2 for every kilometre after that. If there's 5 or more passengers, there's a 50% additional charge. Write an algorithm that does so and so. Now, you got taught a technique called iPodding, and I think it's always important to do this, even in an exam style question, because it gives you that structure and that focus. So, inputs. Well, we've got here allow the number of passengers and the distance. So I'm going to have passengers as an input. And I'm going to have distance. Okay. Calculate the cost of the journey, output the cost. So my output's going to be the cost. And if you read up, we need to charge an additional 50% if the number of passengers is 5 or more. So we need to say if passengers is greater than or equal to 5, or you could just put greater than 4. The process is going to be our calculation. So there's a couple of calculations. We're going to have to, if the passengers is more than 5, we're going to have to add 50% to the cost. So I'm going to say cost equals cost times 1.5, because that will add 50% to the cost. Okay, there are other ways of calculating that. But I also need to work out the cost of the journey. Okay, so the cost of the journey is £3 for the first kilometre and £2 for every kilometre after that. Now, there's loads of ways you can do this. I'm going to break it down. So I'm going to say that the kilometre charge is going to be the distance minus 1. So I'm going to take 1 off the distance, because then what I'm going to do with my cost is I'm going to say £3 for the first kilometre plus the kilometre variable, which takes off that first kilometre, times by 2. Okay, there's a bit complex maths there, so in terms of getting your head round. Right, now to actually make the algorithm. So I'm going to put passengers equals input, enter the number of passengers, and I'm going to put distance equals, so these are my two variables, input, enter the distance. Okay, so the next thing I need to do is calculate the cost of a journey. So I'm going to take 1 kilometre off the distance, because that's going to be how much I'm going to be use that value for my £2 per kilometre. And then I'm going to do my calculation. So cost equals £3, that's for my first kilometre, plus the remaining kilometres times by 2, because I get the rest at £2 per kilometre. There are lots and lots of different ways of doing these calculations, and you can do them all in one as well. So once we've got our cost, we need to see if there's an extra charge. So I'm going to say if passengers is greater than or equal to 5, then, and I'm going to add 50% to my cost. Cost equals cost times 1.5. Now I don't need an else here, because the else part would be, well, cost stays the same. So because it's inside the if statement, it's only going to add 50% to the cost if that's the case. So I'm just going to write end if, and then the final step is print the cost. Okay, so now let's have a look at what the mark scheme for this looks like. Okay, so it's got an example solution, alright, but I'm going to look at the mark bullet points. So here we get 1 mark for input, the distance and the passengers, so that's 1 mark there. We get 1 mark for calculating the distance minus 1, so that's this bit here. And we get 1 mark for times in the previous answer by 2, that's this bit here. And we get 1 mark for adding 3 to the previous answer. Okay. Then it says checks if it's more than 4 passengers, but obviously we are checking if it's more than 4 by saying if it's more than or equal to 5. So this here is my 5th mark. Adding 50%, this is here, that's my 6th mark. And output my cost is my 7th mark. Now there are lots of ways to do this calculation here. As long as the maths is right, you get all 3 of those mark points. So the second question you were asked to do was this one. OCR Airlines allows passengers to carry up to 25 kilos of luggage free of charge. Any additional luggage is charged at £10 per kilo. No luggage, weight, over 50 kilos is allowed. Write an algorithm that asks the user to enter the weight of luggage in kilos, displays an error message if it's over 50, and if it's allowed, calculates the price and outputs this. So once again, I want to iPod. So my input processes outputs decisions. So my input is going to be a weight. Yeah, we've got the weight of the luggage. Okay, displays an error message if it's over 50. So I'm going to have an output that says too heavy. They're allowed to carry 25 kilos free of charge. So I need an output to say free. And I need another output, which is the cost. I've got decisions to be made here. Is the weight over 50? Because if it is, it needs to say too heavy. is the weight less than 50 and over 25? Because if it is, it needs to work out the costs. Or is the weight less than 25? Because if it's less than 25, they get it for free. And then finally, we've got a process. So the only calculation that needs to be made is if the weight falls in between this range of 25 and 50. Okay, so to do that, we're going to work out the cost. So it says £10 per kilo. So if they enter 30 kilos, they only get charged for 5 of them because we have to do a calculation. So it's going to be the weight, whatever the weight is, take away 25, and then we times it by 10. So now we've planned out our algorithm, we can have a go at doing it. So I'm going to start off with weight equals input, enter weight. Now when you're comparing values, I always start with the higher end, because otherwise you end up with sometimes the wrong condition being selected. So I'm going to say if weight is greater than 50, then I need to output, don't I? Print to heavy. So that deals with the first problem. Then I can say else if the weight is greater than or equal greater than 25. Now the reason I don't have to say and less than 50 is because we know it's less than 50, because if it was more than 50 it would have done this print to heavy and then gone to the end of the if statement. And that's why it's important to do it with the highest value first, I find. So if it's more than 25, we know it's between 25 and 50, we then need to work out the cost. So the cost, as I said earlier, is going to be the weight, take away 25, multiplied by 10. And if it's anything else, if it's not more than 50 and it's not more than 25, then that means it's got to be less than 25. So we can just print free. End if. Now there's one important thing that I've forgotten here, and in this else if, once we've worked out the cost, we need to print the cost, because for the other two options there isn't a cost involved, so there's no point putting print cost at the end because we may get an error. So now let's have a little look at the mark scheme with this. So the first mark, it says inputs weight from the user. So here, mark number 1, checks if the weight is bigger than 50. For mark number 2, well, that's what that does. Displays an error message if so. Here we go. That's number 3. Calculates the price correctly. That's mark number 4. Okay. Checks if the weight is less than or equal to 50. Well, that's this one. And prints out the price if so. That's this one. Now, I've done it in one way where I've checked all 3 options. Now, if it was less than 25, okay, you could end up with just by doing a calculation but still getting 0. So here is a different way of doing it, where they input the weight, check if it's more than 50 and provide an error, else calculate the price and then output the price. And there is your answer to question number 2.
And that's everything you need to know about designing and creating algorithms. I recommend you keep practicing it, and we will see you next time for the next lesson.